All right, let's jump right in. In today's networks, we're all facing the same puzzle. How do you give your branch offices that blazing fast, direct internet access they need for cloud apps without, throwing your security out the window? It's this constant tug-of-war, right? Speed versus security. Well, today, we're going to break down how Cisco's SD-WAN solution tackles this head-on. We'll be focusing on the really powerful layered security tools you can build right into the network to protect that direct internet access, or DIA. So, let's get into it.
So here's the game plan. We're going to build our defense from the ground up, layer by intelligent layer, just like a fortress. We'll kick things off by really digging into the main problem, securing that direct internet pipe. Then we'll set up our first line of defense with DNS layer security, get way more granular with URL filtering, and then start looking for evidence with advanced malware protection. We'll even figure out how to peek inside encrypted traffic to find those hidden threats. And at the end, we'll step back and see how this whole thing comes together as one solid, unified defense.
Okay, so let's talk about the core challenge. The old way of doing things was, well, it was simple, but man, was it slow. All the traffic from your branch office had to take this long, winding road all the way back to a central data center. And there you'd have these huge, expensive security stacks that would scrub everything. It was secure, sure, but it was a massive bottleneck. Imagine a retail store trying to run its cloud point-of-sale system through a data center 1,000 miles away. It's a recipe for lag and frustration. So direct internet access solves that performance problem, but it also creates a brand new security headache we have to deal with.
And that really is the million-dollar question we're answering today, isn't it? How do you get that top-tier, enterprise-grade security right at the branch without killing the speed that you were trying to get with DIA in the first place? And spoiler alert, the answer isn't some magic box or a silver bullet. It's about a series of smart, automated, and deeply connected security layers that are built right into the SD-WAN fabric. It's about making the network itself your security guard.
Our first layer of defense kicks in at the absolute earliest moment, the DNS request. You can think of DNS as the internet's GPS. Before your computer can connect to anything, it has to ask DNS for directions, the IP address. Well, DNS layer security checks out that destination before you even pull out of the driveway. It's the fastest, most efficient way to block a trip to a bad neighborhood online, stopping threats before a connection is even made. And here's how it works under the hood. It's actually pretty slick. You've got your users and devices on different networks, what we call service VPNs, to keep things separate, like your corporate traffic and your guest Wi-Fi. When anyone tries to go somewhere on the internet, the local WAN edge device acts like a smart traffic cop. It transparently intercepts that DNS request and says, "Whoa, hold on a sec. Before you go there, I'm going to check with my boss." And that boss is the Cisco Umbrella Cloud, which is basically this giant global brain for internet security that gives an instant thumbs up or thumbs down. Now this is the really important part. We are stopping a potential threat before it even starts. An IP connection to the bad server is never even made. So if a user clicks on a nasty phishing link, Umbrella just says nope and refuses to give out the directions. To the user, the site just fails to load. They probably think the Wi-Fi is acting up. But what really happened is you just dodged a bullet, with almost zero work for the router at the branch. It's an unbelievably effective first line of defense.
Of course, not everything is out on the public internet. You've got internal servers, printers, all that local stuff. You obviously don't want to send those requests out to Umbrella for a security check. That's where local domain bypass comes into play. It's super smart. Think of it like a receptionist. If you ask for the accounting department, she points you down the hall. If you ask for an address across town, she sends you out the front door to check with Umbrella. It makes sure internal traffic stays internal.
So we've got this awesome first line of defense, but what's protecting the protector? That would be DNS crypt. It basically puts that whole conversation between your router and the Umbrella Cloud inside an armored car. Why does that matter? Well, without it, a bad guy could listen in on your DNS traffic, or even worse, hijack it and give you fake directions, sending your users straight to a phishing site. DNS crypt shuts that door tight.
All right, so DNS security is our bouncer at the front door. It's fantastic for blocking known bad places, but it's a bit of a blunt tool. The whole domain is either good or bad. Sometimes, though, the problem isn't the entire building. It's just one shady character inside. That's why we need layer 2, getting way more specific and looking at the exact URL a user is trying to get to.
And this is a huge deal, Think about a legitimate site like SharePoint or Dropbox. The domain itself is perfectly fine. But what if one of your users accidentally creates a public link to a folder full of malware? The domain is safe, but that one specific URL is dangerous. Or a blog platform. The main site is fine, but a user can post some malicious code on their page. We need to be able to tell the difference.
So check this out. This is how the decision logic works. It's like a two-step funnel. When a request comes in, first it hits your personal VIP list, your custom allow and block lists. You get the final say. Always allow this partner site, always block that social media site. Easy. If it's not on your custom list, then it drops down to the smart part of the funnel. This is where the system evaluates it based on the URL's category and its reputation score. It's the best of both worlds. Your specific rules, backed up by global intelligence.
Under the hood, the engine making all this happen is Snort, which is an absolute legend in the security world. It's running right there on the WAN edge device, and it's smart enough to pluck the full URL out of the traffic. Then it checks in with these massive cloud intelligence databases from Webroot and BrightCloud to make a decision. With all that intel, you can build super specific policies based on over 80 different categories. Want to block gambling sites? Done. Want to limit access to video streaming during work hours? No problem.
Okay, so what do we really mean by reputation? Well, it's not just a thumbs up or thumbs down. Every URL gets a score from 0 to 100. As you can see here, anything up in the 81 to 100 range is considered trustworthy. You're good to go. Down at the bottom, 0 to 20 is high risk. Definitely stay away. And this is where it gets really powerful, because you can create smart rules. For example, you could say, sure, users can access file-sharing sites, but only if their reputation score is trustworthy. That lets your team use legitimate tools while automatically blocking some sketchy new site that just popped up yesterday.
Okay, quick recap. We've checked the destination city with DNS security. We've checked the specific street address with URL filtering. Now it's time to actually open the package and see what's inside. This brings us to Layer 3, Advanced Malware Protection, or AMP. We're moving beyond where the traffic is going, and we're starting to inspect what is actually being delivered. This workflow for inspecting files is really smart. When a user starts downloading a file, the WAN edge calculates a unique digital fingerprint of it, called a hash. First, it checks that hash with the AMP cloud, which is constantly fed intelligence by Cisco Talos, some of the best security researchers on the planet. But what if the file is brand new, a potential zero-day threat? Well, the WAN edge can then send the actual file to the Threat Grid malware sandbox. And you can think of the sandbox as a secure, digital bomb disposal chamber, where the file can be safely detonated and analyzed.
Let's just walk through that real quick. It's super efficient. Step 1. The Snort engine sees a file download start. Step 2. The router instantly calculates that unique hash. Step 3. If it hasn't seen it before, it sends just the hash, not the whole file, up to the AMP cloud and asks, what's the story with this? And finally, Step 4. The cloud sends back its verdict. The file is either malicious, clean, or unknown.
This whole process is called file reputation. And the key here is efficiency. We are not bogging down the branch office by uploading every single file to the cloud. No way. We're just sending its tiny digital fingerprint. It's incredibly fast, and it lets you tap into a massive global security brain in milliseconds without slowing your network to a crawl. So what happens to that small number of files that come back as unknown? The real mysteries? Well, that's when they get sent off for full file analysis in the Threat Grid sandbox. And this thing is wild. It detonates the file in a safe environment, it runs it, it opens it, it watches every single thing it does. Does it try to mess with critical system files? Does it start encrypting things like ransomware? Does it try to phone home to a malicious server? It's basically a digital detective figuring out the file's true intentions.
Now, this next concept is a total game changer in modern security. It's called retrospection. It's based on one simple truth. A threat verdict isn't forever. A file that looks totally clean today might be discovered as part of a global attack tomorrow. Retrospection is like having a security system that can travel back in time. The AMP cloud can say, hey, remember that file from yesterday that we thought was okay? Well, it turns out it's actually malware, and bam, you get an alert right away. It means your protection is always learning and always up to date.
Okay, so we've built this powerful three-layer defense. We're checking the domain, the URL, and the files themselves. We should be golden, right? Well, there's one giant blind spot that can make all this work totally useless: encryption. So this brings us to our fourth and final layer of inspection, getting visibility inside that encrypted traffic with a TLS proxy. Here's the problem. Most of the web is encrypted these days, which is great for our privacy, but the bad guys know this, and they absolutely love to use encryption as a cloak of invisibility for their attacks. It really is like a criminal using a sealed armored truck to move stolen goods. It doesn't matter how good your security guards are if they can't see inside the truck. And if we can't see inside that encrypted tunnel, our URL filtering and malware protection are effectively blind.
The solution is a TLS proxy. Now, you might hear the term man in the middle and think that sounds bad, but in this case, we're the good guys, the trusted man in the middle. As you can see here, the proxy sits between the user and the website. It carefully opens up that encrypted session, inspects the contents with our full security stack, URL filtering, AMP, all of it, and if everything looks good, it seals it back up in a new encrypted session and sends it on its way. And the best part? For the end user, it's completely seamless. They have no idea it even happened. So you really have to think of the TLS proxy as the key that unlocks all our other security layers. It's the great enabler. Without decryption, our tools are working with one hand tied behind their back. But with it, our URL filtering can see the full URL path. Our advanced malware protection can inspect any file being downloaded over a secure connection. It single-handedly takes that massive blind spot and shines a huge spotlight on it, giving us the visibility we need for real protection. All right, let's pull this all together and look at the big picture. What we've built here isn't just 4 separate security tools bolted onto a router. This is an integrated, automated, defense-in-depth strategy that's woven right into the network fabric. From that first DNS check at the perimeter, to the URL inspection, to the deep file analysis, all the way to having the visibility to do it all inside encrypted traffic, we've created multiple chances to stop a threat in its tracks.
And that leaves us with one final thought. Today's cyber threats are sophisticated and multi-layered. A single firewall at the edge just doesn't cut it anymore. We've just walked through what a real, modern, unified defense looks like. So the question to take back to your team is this: is your network's defense layered and deep enough to handle the threats of today? Thank you for joining.